Dear students, today we are going to discuss the topic differentiation. In last lecture, we have solved some examples related to exercise 1.1, which is on derivatives of composite functions. Today also we will solve some examples related with the exercise 1.1. Okay, so let's begin. Before that, we will see some trigonometric rules. Okay, so see the first rule: 1 minus cos x is equal to 2 sin square x by 2. This is half angle formula. Earlier you have studied this formula in last year. Okay, so just see this: 1 minus cos x is equal to 2 sin square x by 2. Here the angle is x. In the left hand side the angle is x, it becomes x by 2 on the right hand side. So remember this formula, very important. Next formula is 1 plus cos x is equal to 2 cos square x by 2. Then third one, 1 plus sin x is equal to, in square bracket, see this, cos x by 2 plus sin x by 2 bracket square. Okay, again this is related with double angle or half angle formula. Okay, and then last one, 1 minus sin x is equal to, in bracket, cos x by 2 minus sin x by 2 bracket square. Here these are called as all the trigonometric rules related with double angle or half angle formula. Okay, so here x becomes x by 2, means on the left hand side the angle is x, it becomes half angle on the right hand side. So you will get many formulae by changing the angles. Here means in place of x, if you take 2x or 3x, means suppose if you want this formula, if you write 1 minus cos 2x, then it becomes 2 sin square x. 2x becomes x, as here x becomes x by 2, 2x becomes x, 3x becomes 3x by 2, so on like this. So if you change the angle, then you will get the formula, more formula like this. Okay, so all these formulae are very important to get some differentiation of some particular functions. Okay, now see the next part, that is we have to study some important trigonometric relation. That is, see here first, under root 1 plus sin x upon 1 minus sin x, we have to prove that it is equal to tan pi by 4 plus x by 2. In 11th standard we have solved this LHS is equal to RHS just by using the formula which I have discussed just now. Okay, so take LHS first. How will you solve this? See here, very important relation. So this is root of 1 plus sin x upon 1 minus sin x. Now if you know that 1 plus sin x means what? By that formula you can write root of, see here the formula, cos x by 2 plus sin x by 2 bracket square upon cos x by 2 minus sin x by 2 bracket square. So 1 plus sin x and 1 minus sin x by that rule. So next step, what will you get? See, square root will get cancelled because this is square term, and hence we get this step. Now further adjustment is important. After this step, what we have to do? See, dividing numerator and denominator by cos x by 2. If you divide this numerator and as well as denominator by cos x by 2, see what will you get? See here, you will get 1 plus tan x by 2 upon 1 minus tan x by 2. See here, on the numerator and on the denominator, divide both by cos x by 2, by which you will get this. Because we require the right hand side as tan of pi by 4 plus x by 2, so that's why we adjust like this. Now in place of 1, for further adjustment, that 1 is nothing but tan pi by 4, because we know that tan 45 degree is 1. So how will you use this tan pi by 4 here? See, this one can be replaced as tan pi by 4 plus tan x by 2 as it is, upon 1 minus tan pi by 4 into tan x by 2. This one keep as it is, because of we know the compound angle tan a plus b or tan a minus b. So same adjustment we have done here, that in place of 1 we put tan pi by 4, because tan pi by 4 is 1. So see this term. Okay, so that's why if you know the compound angle formula, then we get tan pi by 4 plus x by 2, because tan a plus b is equal to tan a plus tan b upon 1 minus tan a into tan b. Okay, so remember that. So this is very important relation, and hence we get RHS. Okay, so again see this LHS, and how will you solve this LHS? Okay, by using that formula. Now as a homework, you can solve this. If it is root of 1 minus sin x upon 1 plus sin x, then you will get tan pi by 4 minus x by 2. See here it is 1 plus sin x upon 1 minus sin x. Here it is 1 minus sin x upon 1 plus sin x. Just replacement of, means interchanging of plus and minus sign here. All procedure is same. Okay, so try this as a homework. Now here also, if you change any angle, means if in place of x there is 2x, see here, if it is x, then it becomes x by 2. Similarly, if it is 2x here, then it becomes x here. So x becomes x by 2, like that 2x becomes x, 3x becomes 3x by 2, 4x becomes 2x. So also by this relation you will get more and more formulae which are useful for differentiation. Okay, now we will solve some derivatives related with this knowledge. So see, find dy by dx, and if it is given that y is equal to log of root of 1 minus cos 3x upon 1 plus cos 3x. Here composite function is there, log of this bracket. Okay, so first of all, if there is a trigonometric term, then we have to simplify this by using various rules of trigonometry, and then we have to differentiate this with respect to x. So if you remember that formula, then it is very easy to simplify this term. So see how will you use that formula. So first of all, we will simplify this, then see the simplification. It is equal to log of under root, see, 2 sin square 3x by 2 upon 2 cos square 3x by 2. How will you get this? Since we know that the formula 1 minus cos x is 2 sin square x by 2, x becomes x by 2, like here 3x becomes 3x by 2. Similarly, 1 plus cos x is 2 cos square x by 2. So just we use that formula here. Now what will be the simplification after this? See, very simple. If you see this carefully, then 2 and 2 will get cancelled, square square also will get cancelled, and sin upon cos becomes tan 3x by 2. So this is the final simplification. Okay, so the given function is y is equal to log of under root 1 minus cos 3x upon 1 plus cos 3x, and we got y is equal to log of tan 3x by 2. Now differentiate this with respect to x. Now you know the derivative of log x. Derivative of log x is 1 upon x, but here it is log of tan 3x by 2. So how will you take the derivative? See here, next part in this side. So dy by dx is equal to, see here, 1 upon tan 3x by 2 into d by dx of tan 3x by 2, chain rule. This is by chain rule. derivative of log of tan, so it is 1 upon tan into d by dx of tan, 3x by 2. So next step, see, it becomes 1 upon tan 3x by 2 into, see here, derivative of tan is sec square, so sec square 3x by 2 into again d by dx of 3x by 2. Again here chain rule is applicable because this is not tan x, it is tan 3x by 2. So sec square 3x by 2 into d by dx of 3x by 2. Okay, so see this chain rule here, how we use that. Now next part means answer. See, after completing this derivative, because derivative of 3x by 2 is just 3 by 2, means 3 by 2 is separate and derivative of x is 1. So here we get 3 by 2 only. So just write here 3 by 2, see here 3 by 2, tan 3x by 2 as it is, sec square 3x by 2 is also as it is. So this is our final answer. So in this type of question, first of all we required the simplification by using trigonometric relation or trigonometric formulae. So these two formulae are very important. You remember this main formula, and if you changed any angle here, then x becomes x by 2, just like that here 3x becomes 3x by 2. So as a basic formula you remember this. So if you apply that formula, then you will get the simplification, and after that you can take the derivative with respect to x by chain rule. Okay, so see this answer carefully. So you can prepare many such questions to practice. Okay, so remember this log of root of 1 minus cos 3x upon 1 plus cos 3x. Okay. Now we will solve other question. Now suppose if it is given that y is equal to log of under root, see here, under root 1 plus sin x upon 1 minus sin x, and we have to differentiate this with respect to x. But before that we have to simplify this. But as you know that root of 1 plus sin x upon 1 minus sin x, we know that it is tan pi by 4 plus x by 2, but here as an answer you have to complete that simplification also. Do not write direct answer, just to remember we have discussed earlier. Okay, so how will you get the simplification? See here, log of, in curly bracket, just we use that formula, cos x by 2 plus sin x by 2 bracket square upon cos x by 2 minus sin x by 2 bracket square. Okay, so first of all solve this, don't use direct relation, that is it is equal to tan pi by 4 plus x by 2. You solve means complete all the steps for simplification. So we get this step, square root will get cancelled, and hence we get this step. Again same. Then next step will be dividing numerator and denominator by cos x by 2, and hence we get this step. Okay, so remember this. Then further adjustment is what? See, we know that tan pi by 4 is equal to 1. Okay, see here. So we adjust that term here. So y is equal to log of, here tan pi by 4 plus tan x by 2 upon this 1 minus tan pi by 4 into tan x by 2. That's why we get this simplification. So if you remember that relation, that is root of 1 plus sin x upon 1 minus sin x is tan pi by 4 plus x by 2, then it is very easy to simplify like this. So that's why I have given that relation first. Okay, again here also if you change the angle, then you will get another part here, means x becomes x by 2, just like if it is 2x, then here we have to write x. All adjustments are same. Okay, so after this we have to differentiate this with respect to x. Now see, again here this is logarithmic function, means log of tan pi by 4 plus x by 2. Pi by 4 is constant, remember this. So how will you get the derivative? See, it is 1 upon tan pi by 4 plus x by 2 into d by dx of tan pi by 4 plus x by 2. Chain rule is applicable. Okay, so see this carefully. Now next step. So that's why we get 1 upon tan pi by 4 plus x by 2 as it is into derivative of tan is sec square, but it is pi by 4 plus x by 2, and again we have to take the differentiation of pi by 4 plus x by 2. So chain rule is applicable here because it is tan of this pi by 4 plus x by 2. So tan derivative of tan is sec square, and then d by dx of pi by 4 plus x by 2. Okay, now see what will be the next step. See, it is equal to 1 upon tan pi by 4 plus x by 2 into sec square pi by 4 plus x by 2 into, now see the derivative of pi by 4 as it is a constant, its derivative is 0 plus derivative of x by 2 is 1 by 2. Okay, so derivative part is completed, means differentiation is completed. Now just rewrite this as answer like this. So the final answer will be dy by dx is equal to 1 upon 2 into tan pi by 4 plus x by 2 into sec square pi by 4 plus x by 2. Here this is just a 1 by 2, so 1 by 2, this 2 can be written as here 2 times tan. Okay, that's why it is written like this. So this is the last answer. Okay, so you can change the angle, then you will get more such type of questions depending on this relation, that is 1 plus sin x upon 1 minus sin x, means under root, we get tan pi by 4 plus x by 2. Okay, so if you remember this relation, then it is very easy to solve such type of problems related with differentiation. Okay, so try yourself. Now we will solve next example, find dy by dx. Now see, another different type of example is given here. No trigonometric formula here, just y is equal to log of square bracket 4 raised to 2x into bracket x square plus 5 upon under root 2x cube minus 4 raised to 3 by 2. So this term is complicated term. We have to simplify this term by using logarithmic rules. We know all the logarithmic rules. So see how will you simplify this. By using logarithmic rule, we get y is equal to log of 4 raised to 2x plus log of x square plus 5 upon root of 2x cube minus 4 raised to 3 by 2. This is just by the formula log of x into y is log x plus log y. So here we apply this and then we get this step. Try to simplify as possible as you can. So next step will be, see here, this log of 4 raised to 2x can be written as 2x into log 4. This is again by the formula, that is log x raised to n is n into log x. Okay, so by that we get this step. Plus similarly here also this index 3 by 2 we can write here. So 3 by 2 into log of this whole term as it is. Now again the simplification is possible here. So see what will be the simplification. So 2x into log 4 as it is plus 3 by 2 and in square bracket, now this is log of x upon y, this type of term is there. So log of x upon y means log x minus log y. So hence we get this step. See here carefully. Okay, now further complication is possible here also, because this index is 1 by 2, under root 2x cube minus 4 means index is 1 by 2, so this can be also simplified. So first of all we rewrite the term just like 2x into log 4 plus 3 by 2 as it is into square bracket log of x square plus 5 as it is minus log of, this can be written as 2x cube minus 4 raised to 1 by 2 because of root sign. So further simplification is again possible here. So see what will be the next step. So we get this 2x into log 4 plus 3 by 2 into this minus 1 by 2 into log of 2x cube minus 4. Okay, again multiplying by 3 by 2 in the square bracket, we get this step. See here carefully. So simplification is completed here by using logarithmic rules. Now it is ready to differentiate with respect to x. See here. So if you differentiate with respect to x, then take the derivative here. See, in detail if you want to write, then you can write like this: dy by dx is equal to, now see here, 2 log 4 is a constant term, so take outside of the differentiation and just take the derivative of x, plus 3 by 2 is outside of the differentiation into d by dx of log of x square plus 5 minus 3 by 4 as it is into d by dx of this log of 2x cube minus 4. So in detail if you want to write, then write this step carefully. Now solve this. So what will you get? 2 log 4, and the derivative of x is 1, so just you get 2 log 4 here, then 3 by 2 as it is into, now what is the derivative of log of x square plus 5? Again by applying the chain rule, it is 1 upon x square plus 5 into d by dx of x square plus 5, okay, minus 3 by 4 as it is, again here logarithmic function, so take the derivative like this: 1 upon 2x cube minus 4 into d by dx of 2x cube minus 4, okay. See this carefully, chain rule is applicable. Now come to the next step. So that is dy by dx is equal to 2 log 4 plus 3 by 2 as it is, x square plus 5 as it is. Now complete the derivative, that is here the derivative of x square is 2x plus derivative of 5 is 0, so just you can write 2x here, minus 3 by 4 as it is, 2x cube minus 4 as it is, and d by dx of 2x cube. So see the derivative of 2x cube is 3 into 2 means 6x square, and derivative of minus 4 is 0, so just you write 6x square. So we have completed the derivative here. Now just simplify this, means as a calculation you will get the last answer as dy by dx is equal to 2 log 4 plus, here 2 and 2 will get cancelled and hence we get 3x upon x square plus 5, and then by simplifying we get minus of 9x square upon 2 into bracket 2x cube minus 4. So this is our last answer, okay. So remember this is all related with the exercise 1.1. So 2 questions that we have solved, that is the simplification part, and here by using logarithmic rules we have simplified that given function, and after simplification we take the derivative of that particular function, and hence we get this answer. So first of all study that all rules that we have discussed already in this lecture, okay. So I hope you have understood all these questions related with the exercise 1.1, okay. So thank you.